Hello, I'm back this time with a question from section 14.7, question 18, which asks us to find the local maximum and minimum and saddle points of the function x squared plus y squared times e to the power negative x. As we know, the first step is to find the critical points. So let's do step 1. Find the critical points. To find critical points, I have to find first partial derivative with respect to x, with respect to y, set them equal to 0 and solve for x and y. So, fx. This is function multiplied to another function. I have to use the product rule. Product rule says that derivative of first one with respect to x, which is 2x e to the power negative x plus, so derivative of first one times second one plus first one times derivative of the second one. And set this equal to 0. Fy, there is no y dependence here, so it is basically just 2y times e to the power minus x. Set them equal to 0, both of them. I can start with this one, which is easy one. So if I have 2y e to the power minus x equal to 0, I have this exponential function never ever gets 0 value. That means this is always non-zero. 2 is non-zero. I can divide y is over 0 e to the power negative x, which is 0. That means y is equal to 0 for critical points. Then I can use this fact, y is equal to 0, and plug it in here, which gives me 2x e to the minus x plus x, okay, there's minus sign there, minus x squared e to the minus x is equal to 0. So I can factor e to the x, 2x minus x squared e to the minus x is equal to 0. The same argument works here, e to the negative x never ever gets the 0 value. That means I can do 2x minus x squared is equal to 0. And solve this one, which gives me x equals to 2 or x equals to 0. So I have one value for y, two values for x. Then the critical points are these 2 points. X is 2, y is 0, 2, 0. X is 0, y is 0, so 0. Step 1 is done. Step 2, use the second derivative. Test. Go to your notes or your book. The first thing you'll see we need for the second derivative test to form this function f xx fyy minus fxy squared. So f xx, okay, this is going to be a long computation. So I can simplify first this guy and then use that fact. So it is x squared plus 2 minus x squared plus 2x minus y squared e to the minus x. So this is fx. I have to find partial derivative of that with respect to x. So with respect to x, again product rule, minus 2x plus 2 times e to the power negative x plus x negative x squared plus 2x minus y squared times minus e to the minus x. That's my fxx. fyy is find derivative of this with respect to y, which is 2e to the power negative x minus fxy. We know that if the function is continuous and its differentials are continuous, the order doesn't matter. So instead of finding fxy, I can find fyx, which gives me easier computation there, which is minus 2y e to the minus 6 squared. Okay, let's just keep like that. Then when I'm plugging in values, you'll find the values. Then when you find that, then plug in your points, the critical points. For the first one, 2, 0. X is equal to 2, y is equal to 0. So I don't have this part. That's the good part, good thing. Then I have to plug in values here. Okay. Minus 4 plus 2, it gives me minus 2 e to the power minus 2 plus minus 4 plus 4, these two cancel, this is 0, there's nothing there, 0, 2 e to the power negative 2. And that part, y is 0, so it is 0 squared. So the value I have is negative 4 e to the power negative 4 minus 0. So 4 is a positive, it is negative. So negative 4 is a negative number, e to the power negative 4 is positive. So this part is positive, this part is negative, then the whole thing is negative. If whole thing is negative, then the second derivative test says that f has a saddle point at this point, 2, 0. So that part was for 2, 0. Now let's do, so this is done. Let's do D at the origin. So x is equal to 0, y is equal to 0. This gives me 2 times e to the power 0. This gives me 0. Then the whole thing is plus 0 times e to the 0 minus that part is 0. And again, this time, if I multiply, I get e to the power 0 is 1. So I have 2 times 2 is 4. It is positive value. So the second derivative test says that if d is positive, go ahead and plug in the value of, plug in the point at xx. So fxx. fxx is this guy here. So if I plug in, I get 2. That's it. So I get 2, which is positive. So I have d positive, fxx is positive. Then the second derivative test says that f has a local max, if fxx is positive, then it is local mean at 0, 0. And the value is, let me write somewhere, the value plug in 0, 0 in our original function. 0 square plus 0 square is 0 times. So we did find the critical points. There were 2 critical points. We used the second derivative test. Second derivative test gave us that the point 2, 0 is a saddle point, and the point 0, 0 is a local mean, with the value of the function at that point equal to 0. Thank you for your attention.